How to read the standard normal distribution table. So if you look at the table that I posted in L, you'll see two columns for the values of Z. The first column are negative values starting at negative 3.4, going up to 0. And the second column is right here for values of Z that are positive, starting at 0, going up to positive 3.4. Okay, so how do we read this table? Well, the Z values we want to keep in mind are along the horizontal axis of the standard normal distribution, which we know has a mean of 0 and a standard deviation of 1. So the table is going to give us the areas under the curve to the left of those Z values. Just remember that Z is always in the center because it's the standard normal distribution. And when Z is equal to 0, you can see right here, the area under the curve to the left is going to be 0.5 or half, which makes sense. Let's see if we can try another one. So suppose we have a Z score, again, these are Z scores, equal to 1.47. So you'll look up 1.4 is right here. And then to get the second decimal place, just look at the column 0.07. And the tabulation that corresponds to that is 0.9292. So what does that mean exactly? So if Z is right here, 1.47, is it the area under the curve to the left of that or to the right? Well, 0.9292 is a large number, right? It's a lot. So it's definitely the area under the curve to the left. And that's what these table values give us, always to the left. So keywords in the questions would be less than, shorter than, or smaller than. Those are keywords that you know then to look up the value to the left. So just look up the value just as is on the table. Okay, so if you want, let's try another one. So let's say the Z score is negative 2.33, let's say. So we would go negative 2.3 and then look at the second decimal place in that column, find the corresponding tabulation. It's 0.0099, so very, very, very small area under the curve. So that would be 2.33, negative 2.33 would be very, very, very small. Again, though, even though it's a small area, it's still to the left of the Z value. So keywords, smaller than, less than, things like that. But what if the question has keywords that say greater than, or more than, or taller than? Then you would want the area under the curve, just going to change color here, to the right of a value. So let's say the question said more than 1.47. So the Z score, we want to find the area under the curve that is greater than 1.47. What you do then is you always remember this formula. 1, which is the entire bell-shaped curve, that's the entire area, subtract the area to the left of that value, which we know was, in the tabulation, it was 0.9292. So then that equals 0.0708. And so that's what that area would be equal to on that side. If you add that up, 0.9292 plus 0.0708, you get 1. So that would be the total area under the curve. So you always have to remember to take 1 and then subtract the area to the left if you're looking for the area to the right. So it's always a good idea to just make a sketch of the problem that you're working on so that you can keep the areas straight and look for those keywords in the question. Another way to use this table, we can look for the areas under the curve that correspond to the Z score. So let's suppose the question gives us the area and we're asked what is the Z score or what is the value of X, then we would unstandardize. So suppose the question says, what is the 80th percentile of the standard normal distribution? So we would then look for the 80th percentile. So it's a reverse lookup. This is a reverse engineering problem. So we look within the body of the table. So the tabulations here, and we can see that 0.8000 would fall somewhere between those two values. So we want the 80th percentile. So we want the cumulative area. So this first one would probably be closest to 0.80. And that corresponds to a z-score of 0.84. So z equals 0.84 would be the 80th percentile of the standard normal distribution. Okay, so that's another way. So do lots of practice, get used to reading the table. We will be using it extensively throughout the course right to the end. So it's used a lot in statistics, and you can always refer back to this table. Don't use the table that's in the textbook. It's not the same. It's a little not as straightforward. This table is a lot more straightforward to use. Okay, if you have any questions, let me know.